Alright, so this is lecture number 8 is on PERL. PERL, and you're wondering, I thought this was a Unix class. Yeah, but we're talking about scripting, and you know what? PERL's the most popular scripting language in Unix. Most people would use PERL as a shell. If you've noticed in the first assignment on day 1, I asked you about PERL, and most people researched it a little bit, looked into it. PERL stands for Practical Extraction and Report Language. It's a patch language. It's a more sophisticated scripting language that uses very popular, still supported today. That and Python is pretty cool. So if you get into Unix programming, you want to work for Google, study Python. You want to do system administration and networking, study PERL. And you're wondering, well, I don't really need those languages. They're glue languages, they're patch languages, they're utility languages. You can do a lot of stuff with it. PERL is popular because of the modules. You can take an entire course in PERL modules, actually, not cover all of the usages. The modules are extensions to the language. So you want to do encryption? Just get a PERL module. Run a script, you run the module. So what's a module? It's kind of like a library. So it's like having C++ or C and getting to put in the container or Java in the container class for data structures, or iostream.h for I/O or something. So developed in 1986 by Larry Wall. Very portable, very friendly, very integrated in with the operating system, supported by the operating system. You're going to use PERL for internet development. You got to go through CGI gateway. It's old. So you can run PERL scripts through CGI. If you're going to do a CGI bin directory, you're going to put your PERL files in there. You're going to run it from your HTML code through the HTTP protocol, which is the web browser interface. So it's not the most efficient way of running a script, but if you're working on a Unix server and 99.9% of all the internet is Unix, then it's not a bad tool to be familiar with for Unix programmers, for web programmers, for people in general. It's not a bad language. Has gained very wide distribution and very readily available. PERL programs syntax are taken from shell scripts, awk, and C programs. So it's a combination of a lot of things we've been looking at so far. You write a PERL program and you put it inside of a text file just like you write a script. And you use it the same way, except for the top line has to say PERL on it. Otherwise, how do we know what interpreter to use? So we put PERL in there. So a bunch of statements and declarations like in a shell script. No main, not like C. You don't have to have functions or main or anything. Each call ends with a semicolon. And here's an example of what we put in the top. -W suppresses the warnings. Why? Well, because we don't want the user to sometimes see those warnings. Instead, we could just suppress them, and we can write everything to a log file, and we can figure out what happened. So like I said, PERL completely parses and compiles the program into an internal state that it runs. So it's an internal kind of rich collection of built-in functions and operators that exist. Regular expression capabilities. No arbitrary limits on the array sizes. So it's actually more extendable in some of the languages. Length of the context of strings, or context of strings, and it comes with a symbolic debugger if you're able to use it. So I first used as a pattern scanner and report generation tool. So it came in handy in the beginning as a patch language, as I mentioned before, or they sometimes call it a glue language. Take the output of this program, send it as input into this program, and format it differently. So extract this information out of this file and use it for some purpose over here. So you can write PERL scripts to analyze log data, port information, uploads and downloads, user activities, and very flexible because you can mix and match it with other languages and other systems. So it's very extendable and very portable. So it's now used for system administration, still being used for system administration, client-server programming, writing a port transfer of information from port to port or from system to system. As I mentioned before, CGI programming for www. Not as efficient as some other languages. Where PERL fell short on CGI was when PHP came in. PHP is a much better scripting language for World Wide Web, HTTP, because it integrates into Apache. Perl doesn't integrate the same way. If it did, we wouldn't have to go through CGI. So CGI is kind of a common gateway interface. It's a directory entry into a semi-protected directory, sorta. Problem is, every time the user comes in, the user is actually opening up that gateway and going in and getting access. So, it's a security vulnerability. It's not exactly as secure as if you didn't have to open it up. PHP, you don't have to open up a gateway. You don't have to have access into the server. Anytime you're letting the user come into the server for anything, it's a vulnerability. So PHP as a language runs inside of Apache. It runs along with it. So it's integrated in. There's no open directory. However, you're running CGI open directory, you can run anything you want through it. So you can integrate CGI with Perl, which is the common implementation. Or you could put a C file, executable file in there. Just write an exe file or out.a.out file. Stick it, or a COBOL file, or one of the old compiled languages. Stick it in the CGI bin directory, go through CGI interface through www. User logs onto your website, and the file actually runs. And then the output of the file gets sent through the HTTP protocol. Problem with that? User resources. So every user who logs on starts a new process. You got 5,000 of the same processes running of the same program or the same script. So you run a Perl script. This is why Perl's not used for this anymore. You write a Perl script, you stick it in the CGI bin, you install CGI gateway, you get it all ready to go. You put it out there, and your server load is just increased with every new user who's running that script. So you got like 10,000 people all connected to your network, all running processes. Server's going to go down. So there's other technologies. We've got JSP, ASP. We have so many other different technologies that eliminate this problem, don't create processes. And then the popular one would be like the Java Enterprise Edition kind of concepts with Java, well, servlets is the best choice. Or RMI, Remote Method Invocation, where you have one object out there, and the object that sits out there, and all the 10,000 users who connect to it all use the same instance. So it's one instance services everybody, instead of everybody making their own instance of the object, or everybody running their own process to execute that exe file. So economies of scale makes the server more usable, less weight on the server load. So in essence, a lot of these technologies. Oh, here's a chair here. Where did you come from? Were you not here earlier?
Oh,
You weren't saying, how did we lose a chair? We got one extra person. All right. Anyway, sorry about that. Database access can be done through Perl and other tasks. Well, okay, so when it comes to the internet, PHP, Python, actually Python's a better choice these days, much more preferred over Perl because Perl requires CGI. There's no internet capability associated with it that's gonna be comparable to those other scripting languages. And those scripting languages I just mentioned, PHP, Python, Perl, the three most popular, I would say, scripting languages are server-side languages. What I mean by server-side is that they run on the server. They're not running on the client program. Things like JavaScript runs on the client program, client machine. HTML actually is interpreted on the client machine. Some other applets and things run on the client. So you can take it off the client, you could put it on the server, and then you can have a thin client. Going back to what I was saying the last weekend when we were here, your cell phone is a thin client. It doesn't have to have that much processing to it. You can just connect to the server. So here's an example server script for Perl. The top line has got the use this Perl. And see, notice the syntax is very similar to what we saw in some of the other scripts. You write the script the same way. Print out, what is your favorite color? And then the color is going to be equal to standard input. And you're looking at this going, hopefully you're looking at this going, looks like a shell script. It is. Uses a lot of shell scripting commands. So if you've learned anything about shell scripting, Perl's a pretty easy language to pick up. They both are used by the same sets of people. They both have very similar syntax. But this is the interesting one. We have stdin, standard input. Oh, we actually have standard output and standard error too. We can write standard error to a file. We can write to standard output to put something on the screen, stuff like that. So, and then chomp, we can get something and remove all the white spaces around it and just take the text somebody typed in. You want to chomp because you don't want to have the line return at the end. And everything the person types in for the standard input ends up in the input. So here we're just taking color and we're having it equal to the standard input. We chomp it to just get rid of everything except for the actual variable that we want, whatever they typed in. So it gets rid of the line return. If the color equals, and we're using EQ for equals, that's another option you have in Perl. You could use the equals, the symbol, or you can just say equal, EQ, blue. Then you can print out, that is my favorite. So, what is your favorite color? Well, if it's blue, that is my favorite. Okay, it's a simple script. In running it, we explicitly invoke the program. We can say Perl space options program arguments, or we can use the pound sign and the exclamation point, the directive in the program, as we saw in the previous example. And then we have the program with the arguments. For debugging mode, we can set the -d on it. So we type in Perl space -d, then the program, then the arguments. So it's just kind of like typing in the word Perl space the name of the Perl file you're running. Or put that inside, just like typing in CSH space the name of your shell script. Do the same syntax. So it works the same way as what we just looked at. Or put it in the file and it'll run Perl on its own. Interactive debugging to test the statements. We can go Perl -de and then go 0 for interactive stops and breakpoints and things to put in there. So. Perl supports data types, data structures. So here's where Perl comes in a little bit more than your average shell scripting. We saw arrays, comes in handy. We saw numbers and we saw strings. Everything is generally a string in a shell script for the most part, unless we explicitly make it a number. Yet that's about all you have in a shell script environment. Perl extended that and gave you a lot more. So we have 3 data types. We have scalars, we have arrays and associative arrays, or hashes. So now we have like dictionary lookups and hashes and stuff. So arrays are indexed by numbers, starting with 0. Our shell scripts normally start with 1, but it's okay. You don't necessarily need to know that. And hashes are indexed by string. So let's take a look at some examples here. So from our regular old scalars, we have str is the name of the variable. We have this $sign in front of it. The world is round. Well, that's a string variable. And then we have a numeric value that says that number is equal to 1, 2, 3, 4, 5, or whatever, 134.99. Only difference is the quotes or the no quotes. So the quotes in the first gives it a string. You can put a quotes around the number value, and you could end up with a string instead of a number quite easily. Here's some arrays. At students. So then we're going to go, well, what about the @ symbol in the C script we just looked at is giving us a number. So this is more C-like actually than the shell script we just looked at. Because now the @ script is going to say, well, this is an array. It's called students, so we got Mike, Lisa, and John. And then print student 0 prints out Mike because he's 0. So it's more programming-like because it's starting with 0 on the array subscript values. And then student 3 is equal to Julie, add a new element. At students is equal to 0, I'll empty out the array. Have it equal to nothing. So. And the interesting thing is that there's no predefining integer with a data type. These examples aren't specifying data types ahead of time. So if you're a C programmer, you're used to going integer I is equal to 5. Well, there's no integer in here. There's a number or there's a string. Which makes it a little bit easier. Or there's an array. There's a hash. Here's a hash. So we have this %sign gives us a hash. So what does the hash mean? So Julie is president, Mary is VP, John, it's a dictionary. So 1, you can actually make an easy one. Just go number 1 is ONE, 2 is TWO. You have kind of one word defined by another word. So you can give me a key value combo. So here's an example of print Julie, and it prints out president because Julie's the key, the value is president. So print the key, we get the value. And then print out employee Julie, and then employee John is equal to controller. So we can change the value. So the brackets give us our value versus our keys. And then make it empty. So we got the $sign for a regular old variable, the @ symbol for an array, and a %sign for a hash. It's pretty easy. I mean, pretty easy to remember because we don't necessarily have too many symbols. Lower the symbol set, make it easier to use variables. It's actually kind of straightforward. So strings and numbers, going back to this single valued variables. Perl supports strings and numbers as simplest kind of data. So scalar is either a number or string character of strings. Scalar value can act upon with the operators plus or concatenation. If it's numbers, it's a plus. If it's strings, it's concatenation, yielding a scalar as a result. So two scalars added together is going to equal to a single value scalar. So here's the, actually this is a good note to make at this time, the reference for this Perl structure. If you go onto just search MIT Perl, and you'll see a ton of documentation on Perl. So most of the development for those languages is done out of MIT, so you can get a lot of extra material reading. So if you have an interest in learning Perl, Perl is one of those languages you can learn on your own. It's not a hard language. It's easier than JavaScript, actually. It's pretty straightforward. Scalar values are named with this $sign, even when referring to a scalar as part of an array. So it works like the English word the. So the days is a simple scalar value for days. It's to say that the days 28 is the 29th element because it starts with 0. Days February value of the hash. This is going to be the %sign days. And then number of days, the last index of the days. So remember that $sign in the scripts that we were using for C shell came back and said the number of elements in the array. So this is doing the same thing actually, saying that, but this is the index of the last. So if there's 4 elements, the index is going to be 3. So that's the last index value. Here's the address for you. I didn't remember that was in there. The address of the MIT location. Best documentation if you're looking to learn more. There's hard to find a book on this these days. Actually, it's hard to find a book on anything these days. Everything's electronic on the internet. But this MIT site's got the best data on it. It's probably, it may have changed. The slide size kind of on the old side, but Perl's on the old side too, so it may be still the same. Here is looking at the data structures for Perl. So the entire array and the array slices are denoted by the @ symbol, which looks like these or those. So these days, those days, entire hashes are denoted by the %sign as we mentioned before. So just kind of a recap of the symbols. Namespaces, interesting concept. Each variable type has its own namespace associated with it. So you can have, this is the terrible part. In C programming, you can't have an integer I and a float I, or a string I and an integer I. I can only be used once. In Perl, you can use I for everything. You can have, in this case, it's Sfoo. You can have a scalar foo, an array of foo, a hash called foo. Everything can be called foo as long as they're different types. So the namespace is per type. So you can use with fear of conflicts, yes, same name for a scalar variable, an array, a hash, a subroutine, function, everything. You can just reuse the same name. Kind of dangerous, actually, but very flexible. So here's an example of foo. That's a nice song. I don't know. Sounds kind of relaxing. Huh? It's a prayer? It just sounds kind of relaxing. Here's a context. So it's by each of them of the namespace. namespaces by variable type. Then we have context, we have scalar or list. So certain operations return certain values given the context that you're using it in. That's like the plus that does addition, or the plus, the same symbol that does concatenation. So wanting a list, the scalar, otherwise it gives returns back whatever is supposed to be returned back given the context of the expression. So we have operators for the numbers: addition, subtraction, multiplication, division, anything you'd find in regular old languages. So for integers, the range or the operator to specify a range of integers. As an example, print 1 ... 9 means print 1 through 9. So this is a little bit different syntax than you would actually kind of get in most other languages. So. Concatenation operator, the dot. So print hello.world. Now this kind of reminds me of PHP syntax in a lot of ways. It's very similar. So the dot's used. So you might notice there's a little crossover between Perl and PHP. A little crossover in terms of syntax. Also crossover with C shell. So string repetition operator is the X. So number, string X number. So makes, let's say, string 5. You have 5 Bobs, Bob, 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 back and forth. So times it by Fred times 3 is Fred, Fred, Fred. In this example, concatenation copies a string as many times as the number indicates. Why do you want that? You might be able to put together, remember this is a reporting language. This is a search, extraction, and report kind of environment. So you could report, empty, 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 if there's 3 empty spaces or something, and then times it by, how many, for example, actually, if you dropped 3 classes, you can go drop, 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 or something. I don't know. I'm sure there's some uses of it. Numeric and string comparison operators. Here we have the equals, 2 equals together, 2 equal signs together, or the string, EQ, as we saw earlier. As I mentioned before, you can use both. The not, exclamation point, or the less than, greater than, LT, GT, LE, GE. The column on the right, and this kind of word wrapped a little bit, but the not equals is the exclamation point equal, or the NE for not equals. So the NE belongs over in the string column. Most people go with the numerics because it matches more similar to programming that they're familiar with. The strings used for the symbols, not so common for the most part. We have scalar variables. So they're like those of the shell. This looks actually like a very similar slide that we just saw a few minutes ago, but it's showing you the syntax at the end that $sign always denotes, is used to denote the variable. So Perl keeps track of the types for you. You don't actually have to tell it what type it is. So if it's a string, it always will print it out like a string. So here we have the variable that equals a value. It's an assignment operation. So print the variable in, prints the value of variable. So, which is actually kind of interesting. All you have to do is put the $sign in there. It treats it like the variable. So I have to tell it. So car is going to equal Buick. Count is going to be equal to 1. Okay. It'll keep track of the type for you. Not required to declare or initialize, as I mentioned before. We don't have to say integer I is equal to 1. Don't have to do that at all. Pattern matching exists. So if that variable equals, and then we have the little squiggly line, and then we're going to say, well, give it a pattern. This is a home directory, and it's going to be, this equal to this pattern or not equal to this pattern. And then we also have substitutions that we can put in there as well to replace one pattern with another pattern. So we can make functions. So, we can call functions. And we saw the function already at the chomp. So we have chomp is the second one down here. It removes only the line return character at the end. So if you have hello world and you chomped it, it would take the / in the end away. We have chop. Takes in the single argument of the scalar variable and removes the last character from the string value. So doc would be equal to the Perl document. Well, it would remove the T at the end. So chop something off. So, which is actually very similar to Scheme. Actually, that has Scheme and Lisp actually have a chop and a chomp that remove characters or remove the top like a stack, or remove the end like a queue. So just takes a character off. So chop doc removes the last T. We saw standard input in one of the previous examples. We have standard input, standard output, and standard error. When standard input is used, a scalar value is expected. So we have to assign the input to something. So it reads in the next complete text line from the standard input up to the first new line and uses a string as the value, as we saw before. And we had chomped it to get rid of the line return. So get rid of the pesky line return by chomping it. A is going to be equal to standard input. Get the text. You can actually split out the text. If you standard input was enter your name, your age, and your telephone number. You entered the name, space, age, space, telephone number. Hopefully your name didn't have a space in between. Maybe it's last name or something. Then you could chomp it, and then you could split it. So you could split kind of like a JavaScript function. Separate out the components by the delimiter and turn it into an array automatically for you. So first, second, and third component. Here's your arrays. So it's a list in an ordered scalar data. So an array is a variable that holds the list. And the arrays are dynamically allocated. Because we're not working with a static language, PERL is 100% dynamic. It runs and allocates at runtime. So it's denoted by the @ symbols we saw before. So the array 1, 2, 3, 4, 5 is declared as those 5 values in there. So let's take a look at some operations and functions that are valid on arrays. We saw the assignment. Fred's 1, 2, 3. Barney is going to be equal to Fred. We can copy one array to another array. So if an array variable is assigned to a scalar variable, the number assigned is the length of the array. So I take an array and I copy it to a value. I'm going to get the length assigned to it. Why do you want that? Oh, because you might want the length. So that length is going to be equal to that array. It's going to come back and say, because it's going to return the last index value, which is going to be the size of the array. Access to single elements in the index with the brackets. So note that the @ symbol here is on the array name because of the $sign on the first element. So what we have here is an example to print out $array 0, and then a line return prints out the first element, array R, which is 1. It's not an array anymore. It's not using the @ symbol anymore. It's using the single value, which is the $sign. Which is actually kind of weird because dollars, when I say a $sign, I always think of dollars. Money. If you think of a penny or one value, I always think of multiple values. And the @ sign, I always think of one. You know, like BHEC or @ I2. There's only one item coming next. I think they should switch the two of them, really. I think that dollar is a lot of money. Dollars, money. So I don't know. I would switch them. Undefined, but it's not. It's the opposite. Undefined is return. Well, here's a little joke then, I guess. This is back when people didn't have any money, I guess. When UNIX programmers didn't make any money, so money was empty. It was just one value. And the @ symbol, well, there's the money. There's the multiple ats out there. I don't know. Maybe that doesn't make any sense. Let's see. Undefined is returned when accessing the array elements beyond the end of the array. And so instead of saying it doesn't exist or returning something back that wasn't assigned, so the $sign number array name is used to get the index of the last element. We saw that before. So anytime you see the number sign in there, you're getting a number of items in the array, which is going to be the last index element. So now you can push and pop on an array. So as I mentioned before, you can use an array like a stack, or like a list, or like a queue. You can also use like built-in functions to treat strings like that too. So here's push and pop as applied to arrays. So it's when it's used with an array for information, the value is added and removed to the right or to the left side, depending upon which operation you're using. So push puts something on. So push onto my list, which is the array, this new value, and my list is now equal to the my list new value. So old value is going to be equal to the pop my list. So it pulls off the last value. Push puts it on the list, pop puts it off the list. Shift and unshift functions. So it performs similar operations to pop and push on the left side of the list. So example, at Fred is going to be equal to 5, 6, and 7. And then unshift at Fred A, this value A that you're going to stick in there. So it's like at shift is equal to A at Fred. So you're adding it in. And then at X shift at Fred is going to equal, X is going to get 5. It's going to shift out 5 because we shift over. And the Fred is now 6 and 7 because we removed it. Very similar to Scheme and Lisp, actually, which is two languages that came out as very similar time frame as Perl. The more, actually, if you have an interest in these different scripting languages, take a programming language concepts course. Learn about, there's like a dozen scripting languages out there. They all have some pros and cons and some features that are similar to each other. So we have the sort function and the reverse function. So hopefully you're getting the impression that the arrays have a lot more built-in functions to them. We don't have, well, Visual Basic's got a nice sort to it, but most arrays in C, you can't sort it. Or you can't do something to it as a function. You can put items in, you can take items out, but that's about it normally. So sort returns a sorted list of ascending ASCII order without changing the original list. So it doesn't change the original list. Reverse takes the whole list, turns it around, makes it the opposite direction, returning the resulting list. So if A was 1, 2, 3, and we reversed it, we get 3, 2, 1. If B is equal to the reverse of A. The sort, we had sort up there. Okay, we have the chomp function. Chomp function, as I mentioned before, pulls off the line return at the end. So chomp stuff, the chomp at stuff returns ola off of the end of it. So, returns, excuse me. Chomp works on variables, but it also works on arrays. This is showing you chomp with an array. The previous example showed you chomp with a variable. So at stuff is the array, hello, hi, hola. The /n at the end got chomped off of the last element of the array. That's a Spanish, actually. For you non-Spanish speaking people. Anyone know Spanish? I hear Spanish is easier to learn than English. Okay. Now I got you woken up again. Filtering a list. So, and I warned you ahead of time, some of this stuff is a little bit dry. Unfortunately, this is the dry weekend because this is all of the miscellaneous commands and scripting languages I have to introduce you to. So grep, we know about grep. Function may be used to select from a list. So toys, GW, cars, race cars, truck, blue car, and train. At cars equals grep, car, toys, so we'll get car out of there. Print at cars, and car is going to be car, race car, and blue car. So this is another feature of Perl. It uses UNIX commands, so we can use grep inside. Anything you can do in UNIX, you can do inside of Perl without having to run system to run a system call or system command, which is what you'd normally do in C. So Perl is more integrated into UNIX, so you can run UNIX commands without having to treat them like external commands. External commands of UNIX, internal commands of Perl, all treated at the same level. Mix and match, no problem. That's another reason why people like Perl. So grep from any list, we have at demons is equal to grep with demons and something. So iterating through an array, we can do it C style or we can do it C shell style. We just saw C shell style with the foreach loop. So we just went through that syntax actually. But to refresh your memory on the C style, that's the regular old for loop. So if our I is equal to something, I is less than something, I plus plus, print out everything in my array I, as an example. Or the for loop for each element in I, print out each element. So you got both, but you don't get in C, you only get one of them in C. So we have an array of elements that comes through in standard input, as I was mentioning before. We could take the standard input and put it into an array, but just by going @ a is equal to standard input. So in a list context, the standard input returns all the remaining lines up to the end of the file. Each line is returned by a space in the elements in the list. So in this, we read the standard input as a list of context, so we can get all of the arguments, all of the array elements in, and just assign it to an array. And then the spaces are the input values. So it makes it easy to take input and put it into an array or into a single variable just from standard input. So there's no conversion that has to happen, is what I'm saying. And this is interesting because this is what we get as natural behavior in C. And most people, when they took their first C course and you learned about main and the command line arguments that come through, and you go, wow, I can ask for on the input of the function of main, you can list out command line arguments. And then you can take those arguments and print out 0, 1, and 2 and get the command name and all of the things you typed in. And they were just like so surprised that, you know, this is a great feature. Nah, it comes from PERL and scripting languages. So it's the way we get arguments to come in. So @arguments is an array. It contains the command line arguments, which is actually kind of funny because it's the same syntax and the same concept. Different between different languages. Some languages treat the arguments like strings, which is what you get in most scripting languages. Some of them treat it like a character array or character string, or excuse me, string array. String array, character array, or flat strings. There's some other variations. So the @arguments is an array. It doesn't include the program name, where it does in C, which is interesting. So the 0 contains the program name, and then the 1 is the first argument to the second argument. So using scalar context to determine argument count. So if @arguments doesn't equal 2, and they didn't add 2 arguments in there. So we're going to print out something about the usage. So hashes, collection of scalar data, individual elements, key value. So the index values are the arbitrarily scalars called the keys, and they're used to retrieve the values. So it's kind of like an array where we have 0, 1, 2, 3, except for now we can have Bob, Mary, Joe, Larry, the names, and then we can have the ages as the values or something. So it's nothing more than an elaborate array structure with named keys, and the elements of the hashes have no special order to them, where they do in an array. An array has a first, a second, a third. Hashes don't have an implied order. And the hash in here is denoted by the the percent sign symbol, as we saw earlier in the earlier examples. So elements of a hash are referenced by the hash name, and then we have the curly brackets with the key. So instead of saying solid brackets, O, 1, 2, 3, whatever, we can say Bob, Mary, Joe, and it'll come back with the ages that are associated with Bob, Mary, and Joe, depending upon which one we selected. So here's some examples. Car color is equal to Buick, comma, yellow. All right, my color, car color, Buick. My color is now yellow because we assigned it the value that was associated with Buick. So all the Buicks are yellow, all the Fords. Buick is a kind of an old American car. Just say something more modern. Scions. Anyone own a Buick? Actually, no one owns a Buick. I think there's a lot of Buicks on the East Coast, though. We don't get Buicks in California. They're gas guzzlers for the most part. I shouldn't say that. They probably have a hybrid Buick now or something. Do you guys have Toyotas, Hondas, Priuses, hybrid vehicles, Fiats? I got a Fiat. That's because Fiats are popular out here. This parking's limited. So. What's the most popular car now? It used to be Hondas. You guys drive BMWs? What do you guys drive? Peanut? What did you say?
Everything.
Everything. If it has 4 wheels and runs, you drive it. Well, you're all college students, so it's really hard to determine what you drive. Some of you drive the VTA. Or a Caltran, depending upon where you're coming from. Better yet, United or Southwest. That's my vehicle, Southwest. All right. Percent copy is equal to new percent original percent copy one hash to another hash. You can do the same thing with arrays too, by just making the equals. More hash examples using the arrow equals and the arrow operator. So color equals, and we're going to say Buick is yellow, GE is red. We don't have GE cars anymore. Okay, so what can I say? Toyota's yellow, Honda's red, Fiat's are blue. How's that? More modern day comparisons. So we have functions. We have key functions that we can apply. So the keys with the hash name yields a list of the current keys in the hash. So we can get the Buicks and the Hondas and the Toyotas and the Fiats out of there. Here's an example usage where we have keys with the hash name is equal to keys hash name. So once for each one of the keys of the hash Fred, for each key in keys of the hash table Fred, print out at the key we have, well, what is the key for Fred? So we have this value. So this key equals this value, and then show the key value combinations. So the word key is the symbol here that we're using in keys. For each key, keys for Fred. So it's a function keys. Function name is keys, and we're getting the keys. Order of the hash keys is unpredictable. That's an interesting test. So you can print it out 5 times. Theoretically, it'll print out 5 different orders. Maybe print out a couple of them that are same. Special percent environment hash stores the environment variable, so you print out environment shell. Shell is going to be equal to bin sh. So this is the shell that was picked. Just like the keys, we can print out the values. So values is a function. So just like keys in the other example, we just say values. It gives us a value for each one of the keys. Problem though is you have to almost print out the key value combo, otherwise you don't know what values go to which keys because you don't know what order and it's not predictable. So, and here it gives a list of current values for the hash name in same order as keys returned. So keys hash name is going to give us the values. And I should say it's the same order for the same iteration. So if you print out all the keys, you have all the associated values that are for those keys in the right order. Otherwise, how can you tell which value goes with what key? But the order in which the key value sets are returned might change with different iterations, is what I'm saying. So last time we had Barney, Flintstone, Jerry, and Smith. No rubble. And then we have the last names are going to be equal to, well, grab the values of the last names that are associated for the values for the key names. Each. We had the foreach in the previous example. Now we have each. So print out each pair. Each gives us a return of the key value pairs as elements. So instead of getting the keys, instead of getting just the values, each returns both. Used to iterate over the entire hash, print out everything, examining each element. So example, while first, comma, last, so a scalar first, comma, scalar last, equals each of the hash called last name, print out the last name of first is last. So we can take and put the key values out there in terms of first and last as their variable representations. Not bad. Why do you want to do that? Well, think about the concept of a search engine, actually. You go out and collect a bunch of data. You have a bunch of data. You put it in a hash. And you say, this is the text we're going to put out on the screen, and this is the URL we're going to go to when you click on it. And then for each one of these sets, we don't know what the sets are. Just print it out to the screen. So we could display the results like that for, let's say, for a search engine. Probably not going to use Perl for doing a search, but we could if we wanted to. Removes hash elements. So the delete removes a hash element, takes a hash element as a reference. So delete last name Barney, which is going to be a key, deletes the key value pair. So last name has only one key value pair now. Checking the hash keys or the values. Checking if true or false values exist for, let's say, for example, if temp John, he's in there. So true values, true or false values. Checking for an existing key. If exists John as a key, then no, do something with it. Checking for an existing key and a defined value. If this key has this value, then do something. What the concept is leading to. Undefining a value. Undefined John. Maybe you had balances or something in there. And you want to leave John in there, but you want to take the value out. He has no balance. Or delete the key value pair from the hash. Delete John. So take him out instead of just undefining him. Or check to see if the hash contains anything. Did we let everything? Is there anybody in here who owes us any more money? Nobody's in here. So we removed it all. So Perl supports if, for, while, similar to C. Also supports the foreach, which is the construct from the C shell. So for example, for each example, if the list or R iterating over is made up of real variables rather than some functions, it would return the list value. And the variable would be used for iteration in the fact of an alias instead of an alias. So here's an example. Let's just go to the example. So numbers is 3, 5, 7, and 9. For each number in numbers, number is going to be equal to times equals 3. So numbers is now because we just multiplied it by 3. So we got 9, 15, 21, 27. Okay, so we didn't print it out. That's just that is just a comment at the end of the code giving us that. Basic I/O. So it also supports the standard input, like what we saw with the C shell. So input from standard input. So it uses the variable with the $sign and the underscore to contain the line right in. So, or $sign and the name of the variable, I should say, to contain the line from the standard input. So A is equal to standard input. At A is equal to standard input. Leads all the lines or a single line. Next line. Because you're going to get an array versus a flat variable. Typically, while define and the line is equal to while define, while exists and equals the standard input. Read up in all of the lines that you're typing in. Because yeah, it might have multiple line input. That would be the case, let's say, for example, if you had search results that came out, you might have one, you might have none, or you might have multiple lines that come out of that. So using the diamond operator. So they call it a diamond operator. And operator gets data from files or files, more than one file, specified by command line, invokes Perl program. So it looks like the argument very similar to the at argument variables array. So while do we have something? So we put the diamond symbol in there, then print out something. So it's used for data from files. Very similar to, well, the opening and the closing arrows, less than and the greater than arrows, it's kind of like file I/O, so it's kind of easy to remember. Or it's not file I/O. Redirection operator is what I meant to say. Yeah. Output to standard output. So print from normal output, printf or formatted outputs. Works both with standard output, which is what we're using. So that's standard input, standard output. You can also use standard error in here as well. It might be coming up, but I'm not sure. We have regular expressions. So Perl supports the same regular expressions as in sed. So the same Unix command sed supports the same features. Oh, if you weren't here before lunch, because I have one extra person, but I don't know who it is. We X'd assignment number 7 on regular expressions. You weren't here. Are you new? Did you come after lunch? Okay, good. This is for you. We have no assignment 7. I took it off. I just arbitrary. Actually, you guys voted for it. You guys said you didn't want it, so I accommodated your request. Took it out of there completely. Added those 5 points onto the CSLL. So make sure you do a nice CLL essay, and then you're in good shape. Right, number 7 was on regular expressions, but I thought it was a little too complicated. I'm going to pull it out for the online students too, so they don't have to worry about it either. I'm going to try to make things fair. So. Actually, this class is just like the online class. Except for, instead of you sitting here listening to me, you watch the videos. Huh?
You can even ask the doubts.
Oh, you can always send me an email message too. Or post a message to the class and say, I don't understand this, and then I answer questions for you. Actually, I answer more questions for those guys than I do for you guys. Because I only see you, like, while you're asleep for the weekend, and then you go home. And then you don't ask as many questions. Those guys, they're constantly asking questions. I think there's more interaction in the online class than there is in the face-to-face version of this class. Seriously. And that only goes for 8 weeks, so you only go for 3 weekends. But let's not talk about the weekend thing again. It's already a long weekend, and it's only, I don't know what time it is yet, but almost 4. Wow, we're almost done. Let me just finish this lecture. How's that? Okay, so let me get back on track here. So we have the equals with that little tilde sign as the match operator. Come back soon. I feel the attendance coming. I feel it coming on. Takes a regular expression operator on the right side and changes the target of the operator to some value. So the target of the equals and then the tilde sign operator can be any expression that yields some scalar string. That's what I was talking about, split. So very similar to JavaScript, actually, we have a split. Well, JavaScript is a scripting language. A lot of scripting languages have a lot of similar functions, and they're usually named very similar names. So a split's a function that takes a regular expression and a string, and looks for all occurrences of the regular expression within that string, like a space or comma. And parts of the string that don't match the regular expression are returned in sequences as a list of values. Voila, that's how you do it in JavaScript. That's how you do it in other languages too. You split out so you can comma delimit or something, some line of text. So what are you going to do? Here's an example of a split. So we have the line is going to equal to some URL address here. And then we have the fields. We're going to split it by the /::/. Well, we're going to use it by //. So if we split it out, now we get the fields of Maryland 118 and 120 because we're using the colons as the split character. If you have all your input, it's all space delimited, which means there's a space or a comma or a colon in between everything. You split by the colon, you get all the sub little pieces in between all the little symbols in there. So, joins the opposite of split. So we take and we join. So it takes a list of values and glues them together with a glue string between each one of them. And what's the glue string? At this point, it's going to be that colon. So outline is going to be equal to join all the fields in this array. So you take the array that's inside of fields and you join them together using a colon in between each one of the words that's in there. Opposite of split. So we got some functions here. Define a function, user function. We have a sub function. Statement 1, statement 2, statement 3 returns a value at the value of the return. So the return value is the value of the return, if there is a return, but we have no return here. So that statement 1, statement 2, statement 3 would be executed. So it's a definition of creating a sub and then a name of a sub. So it's a function. When you call a function or a subroutine, it's actually called a sub, by the way, for subroutine. Variable is equal to my routine and some parameters inside of it. That is very similar to a C function call, except for in C we have data types. We don't have data types in Perl. Well, we do have data types, but we don't explicitly, it's not a strongly typed language. So we call this a sub. Other languages we call it a func, F-U-N-C, which is a Lisp scheme variation of this. Or we did call it a function in JavaScript, or we call it a function in other languages as well. So it's called a sub. At the array is going to be equal to my routine and some parameters. So if function returns an array, we can have it equal to an array. If it's a single value, I have it equal to a single value. We have function arguments. So function invocation in the following by a list of the parameters, by a list within a parentheses, sends information to the function. So causing the list to be automatically assigned to a special variable name. Parameters. They're named parameters. So at the duration of the subfunction, we have 0 for the first element. We have the entire array element private to the subfunction. So we can have private variables inside of the function. So we can use the my operator. So here's a subfunction. It's called add. And my, and then what do we got here? Sum. Make sum a local variable. And then we're going to say for each of these items, sum plus is equal add each element together, and then return some very C-like return statement there. This is the last element. So the keyword my makes it personal. It's mine inside of my function. So you have global scope for the entire script. If you use my, you have local scope. So by default you have global. If you define a my somewhere inside of a function, it's local. If you put it outside and then you have a function, it's only visible outside, not inside of the function. So my is private. Then we have semi-private. Well, we can use the keyword local. So semi-private variables using local as a keyword instead of my. Those are visible to functions called from within the block in which those variables are defined. So if it's in a particular block, local is going to be for the whole block area instead of just being private within a certain block that you're working with. Requiring variable declarations. Programmers may choose to require declarations. So remember before I said you don't have to say integer I. You can just say an I is equal to 5. You can just say I is equal to 5 and declare it. Or you can turn it on so you have to declare the variables. What does that mean? It makes it strict. So use strict or use strict variables. If you use that parameter as a function on the top when you run the script, then everything in the script requires a declaration. Why do you want to do that? So you can check stuff ahead of time. I don't know. Treat it like a compiled language instead of a scripting language. You can get all the benefits of a strongly typed language. So a compiler will be strict in requiring that variables must be declared private with my. Otherwise, variables must be qualified with package names. Where did this come from? So in parsing arrays, we have this variable score, and it's equal to average of math, English, and French. Passing arrays, so we're sending math, English, and French to the array, to the function average, and we're having that equal to score where it comes out. So passing arrays as references to arrays. We can pass hashes as well. And then we can pass references to hashes. We have pass by value, pass by reference, same thing as supported. So, as in terms of the arguments. So we also have signal handling. Signal handling is a piece of cake. It's just like C signal handling. It's the same thing actually, same signal names. So special hashes, the hash signal is used for signal handling. So we have a signal and then we have a routine that's going to go along with it. So it's actually kind of simple. So we have hash keys that are signal names. Here's a couple of signal names. SIGCHLD, common UNIX signal names. And then the hash values are the signal decisions. So we have SIG INT might equal ignore, or SIG INT might equal default, resetting the default, or ignoring the signal. So we can set certain names that are associated with the signal decisions for certain activities to occur when the signal happens. No signal handling on the final, no PERL on the final either. So. But it's interesting. This is at least useful. So file handlers, this is what I was saying before, the standard input, the standard output, and the standard error. This is how they're done. Recommended to use the uppercase letters in the file names. PERL doesn't require uppercase letters, but it's recommended so you can see what it is. Other scripting languages don't require uppercase. So, standard input is for standard input, output, error. So opening a file for reading. So you're going to open file handle, the file name. And then you have die. This is such a crude language. In the old days, people didn't care about politically correct statements or anything like that. We had kill. Now we have die. Die is equivalent to open the file or die. Does that mean go away? Die, just go. So not a word we hear too much in programming these days, but it's part of PERL. So opening a file for writing using the directional operators works for file handling or appending. So the single or the the single or the double directional operator for append. So open the file handle, open the file handler, then redirect to file name, die, sorry, we cannot create the file name. Die is kind of like a abort. So in terms of file handles, in terms of writing a file, that was opening a file. To write it, note a comma after the file handler. No comma after the file handler. In this case, we had a comma in this one, which is kind of weird. Open this, comma, then write it out to that. This one just says print this file handler, and then print to the file handler, which is the name of the pointer that's pointing to this file that we have out there. Hello world. So Perl provides a -op file, which tests just like the shells. Test a file, make sure it exists first before you start writing to it. Otherwise, you're gonna, write to a file that doesn't exist or have a problem. So you can execute UNIX commands from a Perl script, as I mentioned before. So to capture the command output, use the command substitution. So these might look a little familiar, capturing output in the scalar for who. And we have single brackets now because it's not a quotation mark, because it's not a string. It's the command who. So capturing output to an array, output for who. To execute a command without capturing the output, we can use system. System who. This actually comes from C, or is used in C. So you can run system. It's a system call, actually. UNIX system call to run a command who, if you want to run it that way. So reading files. I thought that was the guy checking the locks on the door. You sounded just like the guy who checks the door. So reading directory files. There's this thing as well called the Perl cookbook. If you Google Perl cookbook, which is actually kind of interesting, you'll see a nice. They actually have colored cookbooks. So there's a red book, a blue book, a yellow book. Different levels of different commands and sequences that you can use for Perl, essentially. They're just the names of the books. Cookbook, well, because you're cooking up a script. So if you're creating it, which is why they call it a cookbook. So you can use open directory to set up a directory handle. You can use read directory in scalar form to read in a directory contents or information for a directory handler. So these are different ways of automating the file I/O and the reading and writing of directories and files. So use read directory in a list context also to read all the directory information. So other directory routines might be close a directory, rewind a directory. How do you rewind it? Well, you can rewind by going back to the beginning of the start of the directory sequence and coming back out of all the subdirectories you were in before, which is a nice rewind command. So database manipulation. So most Unix systems have a standard library called the DBM. Allows users to store collections of key value pairs and a pair of disk files. It's not a database like MySQL. It's not really a database, but it is a database. It's persistent storage that you can keep in a Unix system. It's really a file system. So Perl hashes might be associated with a DBM, a database manipulation file. And through the process is similar as opening up a file, actually. It's just like a file, but it's a hash file. So it's a dictionary. Actually, I think dictionary is a more proper word for it. They call it a database, though. Not a relational database, obviously. More of a dictionary database. So we have a DBM open function, associates with a DBM database with a DBM array. Open it and create an array out of it. And here's some examples. DBM open, my array, with this name, and this mode. Well, what's the mode? It's the same mode we get with databases, with file systems and change mod. Read, write, execute. So do it for the user, do it for the group, do it for others. Or let's say delete this key out of it, and then write it back out at the end. So open up a database, change a key, write a key. So don't confuse it with a database like a regular database, though. It's more of a dictionary database. Perl also includes debugging utilities. Perl -D gives you the debugging mode. So H to print out the help messages. T for stack trace. S for single, that should say single step for stepping through. N for the next step. F for finish. C for continue. System calls as mentioned before. So we have the interrupts. We also have support for system call interface. We've seen system to run a system call or to run a command in Unix. We also have the system calls, open, close, print, stuff like that. So it provides an interface in many of the Unix system calls. And it's via PERL functions that are wrappers around the system calls. So if you don't like running system calls, because system calls are kind of tedious, you can find you can combine 5 or 6 different Unix calls together to make one API call, which is what you have in C. So the C printf, as an example, is about 4 or 5 different lower level system calls. PERL has the same thing. It's a higher level API. PERL commands that run the lower level system calls for you. So the interface uses dependent on the implementation, the version of Unix that's being used. There's about 3 or 4 different versions of PERL. So depending upon the PERL version, your APIs might differ because it's an API, application programming interface, that's inside of the PERL build. So it might have a slightly different implementation of a wrapper on your system calls. Long story short, the printf might work a little differently, and it does actually. The syntax of the API might differ a little bit. Same thing true for like Python actually as well. There's a lot of variances in the system calls. Is there somebody at the door? No. Okay. PERL modules. This is really the strength of PERL. The modules. So PERL modules may export symbols to your namespace. So you might use a use to import the module. So use CGI, or use encryption, or use this package. Think of a module like a library. And think of it like third-party applications and tools and things that you can use inside the scripting language. So they're additions or extensions on the language. They call them modules. So they may request only certain symbols be imported or use other symbols out of the module. Because what ends up happening with the PERL modules is you get the same problem you get with multiple includes in C. So if you're familiar with C and C++, when you compile something and you include stdio.h or whatever, and then you include another stdio.h, you have 2 different, you can only use one, but you can include this package or this module out of this one and this one out of that one, which is what you get mostly with the import in Java as a functionality. And then you get the whole package concept in Java. Well, you have packages in PERL that do the same thing. So the package concept is not new. In your package, you have a bunch of modules, and you import the packages, just like you do in Java, except for instead of using the word import, you use the word use, and you bring it in. So it's the same concept as what you might be familiar with. We have module names that should all be in lowercase, as an example. Module files, package names that should match. So we have a module name, a file name, and a package name that might be associated with it. So imagine an elaborate system to keep track of different modules so that we can load them in from different packages. And then we can use multiple namespaces. Actually, if you're familiar with C++, the use namespace command, if you're familiar with that, is like the package equivalent for some reason. So it's the same concept of the namespace in PERL. So most modules should load in the standard exporter module. So 3 different special types of use exporter. Well, which are we going to create here is an exporter sort of like the namespace, and the package is sort of like the package in Java. We have both of them supported in PERL. So use exporter, put inside of there all the symbols of all the packages, of all the modules, of all the pieces of information that you're going to use. So any modules need to be initialized within the code, and then the function definitions need to be declared. So it needs to return some value to indicate success. Otherwise, we don't know if the module actually got loaded. So. And that's everything you ever wanted to know about PERL. Not really. You can study PERL as an entire course, actually. What I wanted to do is kind of give you an overview of the language, a little bit of information on the packages and stuff like that, or the modules. The big support for PERL is really the integration with Unix, and the fact that it's one of the core scripting languages used in Unix. And it's still very popular, actually. And it is popular because it interfaces quite well, uses Unix commands like grep and sed and awk and everything, uses directional I/O, uses standard input-output and error, uses everything that Unix uses. So it's really a Unix programming language that runs in a shell. And Perl is a shell. It's a shell scripting language, just like the other shells that we have. So if you remember that first assignment, most people went, when I listed shell, Perl, they went, oh, Perl's a language, Perl's not a shell. Technically Perl is a shell. You write a script and you run it in Perl, just like you write a script and you run it in C shell, or you run it in Born or Bash. It's a shell. It runs in a shell environment. It's a scripting language. It's a little bit more sophisticated than some of the other shells we looked at. So we looked at C shell, so you can compare it with something like Perl. You don't need to know anything about any one of these languages. The only thing you really need to know is that you can write scripts with it. And the scripts, you can say what to run it in, what shell to run it in, and the commands that you're using in these scripts are very particular to the scripting environment that you're writing it for. So what works in Perl, you don't run it in Perl, it's not going to work in C shell. But the funny thing is inside of Perl you can run a lot of C shell. It's like C shell plus a bunch of other commands, plus a bunch of C stuff, actually, C syntax. So that's pretty much all I can tell you on your introduction to Perl. So I'm going to stop this video.